sorry. Sorry, I'm actually watching this. All right. That's better. Okay. So I have my worksheet out from yesterday. We had done the front. So today we're going to kind of split up the back just because I know doing 6 word problems in a row can be kind of torturous. So we're going to do 2 at a time. So we're going to start with numbers 3 and 4. I'm going to set them up with you, and I'm going to kind of give you a few minutes to solve them, and then we'll go over them, do the next 2, same thing, and then do the last 2, and then kind of wrap it up. So we'll start with number 3. And our main goal being, we're going to read a problem, we're going to draw a picture, so that's a big thing. And then you guys, I'm going to kind of help you decide what you're using, and then you're going to set up an equation and solve it. So find the angle of elevation of the sun. We had done one like this yesterday. If a 48.6 foot flagpole casts a shadow that's 63.1 feet long. So I just go over here. I'm going to actually draw a flagpole. So here we go. Got a little flag. Cha-cha-cha. Up here is the sun. The sun's rays come on down and hit the flagpole, and that's what makes a shadow on the ground. So just as a reminder, the shadow is here. Sometimes people tend to want to make that the shadow. Now those are just the sun's rays coming down at us. So as I look at this, I say, okay, well now I need to kind of fill in what I know. So it says the 48.6 foot flagpole. So this flagpole is 48.6 feet. Okay, so I would say 486, 48.6. And it says the shadow is 63.1 feet long. Remember, shadows on the ground. And obviously, well, it's not so obvious. Depending on the time of the day, sometimes your shadow is super long. Sometimes it's you barely have a shadow, and it all depends on the angle of the sun. So that's what we want to find. What is this? Angle of elevation. That's this, because right, elevation is when I look up and try to see what the angle of the sun is. So in a second, you are going to go back and you're going to say, okay, I have this. I don't need to solve for everything, which is nice. I really just need to find what this theta is. So you're going to say, what 2 things do I know? Opposite adjacent hypotenuse. You're going to say, what trig function should I use? These sound familiar to us because we've been doing them. We've been doing chapter 2 since October at this point, so we're kind of over this chapter, but we'll finish it up today. And then can you write an equation and solve? So you are going to try that part in a minute. Can you kind of finish that out? Just reminder, since you are solving for theta, you would use an inverse. But while I'm here, let's do kind of 2 at a time. So let's set up 4, and then I'll give you a few minutes to try to solve those. This one says angle of depression, which we haven't seen yet. I'm going to show you what that means in a second. So we have this television tower. The angle of depression to a point on the ground. Some of these got a little weirdly worded. That's why I'll help you set it up. 36 meters from the bottom of the tower is 29.5 degrees. Find the height of the tower. Okay, I have no clue what a TV tower looks like, so there we go. Nice little tower. There's a wire here that's going to go to the ground. We should always get a right triangle out of it. So if nothing else, you draw a right triangle. Now, when it says the angle of depression is when you have kind of a vertical, or excuse me, horizontal, and you're looking down at something, right? If something's depressed, it's going down. So that actually means that this angle is the angle of depression. And you're probably saying, well, that doesn't help me. It's not even in the triangle. You're right. But for now, we're going to label that as 29.5. So it's a little funky once again when it says depression, because it's from the horizontal, you're looking down. It ends up being outside of the triangle. The nice thing is this angle of depression and this angle are the same thing. So I just always kind of take what's out there and then just throw it in the bottom there. So that will always happen, which is kind of nice. So you don't need to do anything extra, even though it's a little weird. It's just remembering where it goes. It says to a point on the ground 36 meters from the bottom of the tower. So from the bottom of the tower to this point is 36 meters. And it asks us to find the height of the tower. So So we want to find how tall it is. So for this one, you're going to go back and label. Just think about inside the triangle, right? We know this angle. From here, what side do I know? What side do I need? Opposite, adjacent, hypotenuse. What trig function should I use? And then can you write an equation and solve? So we'll kind of just do a few at a time just so we're not killing ourselves here. I know word problems aren't the most fun to set up, but I will help you draw the picture. But then from there, this goes back to our review steps of just how do I solve for a part of a triangle? I'm going to label what I know and what I need. I'm going to pick that trig function, that's the big one, and then you're going to try to write an equation and solve. So I'm going to give you a few minutes. I'm just going to do attendance. If you have questions, let me know. If you need a calculator, you can come grab one. But you are going to try those two problemos. All right. This is block 2. We got it. No, Danny. Okay, so let's go over these two, see if you were able to correctly label what you had, what you need, what trig function, and if you could write an equation. So when I look at this one, I say, okay, from my angle, this would be opposite, so I know opposite. This would be adjacent, right? My right angle's right there. I don't even care about hypotenuse. So my trig function is going to be tangent. Okay. So that'll at least help me organize it. My equation is going to be tangent of my angle, which I'm just going to call theta because I have no clue what it is, equals opposite, which is 48.6, over adjacent, which is 63.1. So that's not too bad of a setup. And then I kind of give you a little hint, and I'll always try to give it to you as well if you're kind of doing something on your own. To find theta, you are going to do the inverse tangent of 48.6 over 63.1. So I just grabbed my calculator, excuse me. The inverse tangent of that, I have no clue what it is, so you grab a calc and you throw it in. And your final theta is 37.6 degrees. So that's the angle of the sun at that particular time. The angle of the sun changes throughout the day. But at least you know at that time. That's what it was. Any questions on how we solved for number 3? Okay, so number 4, kind of same idea. We're just going to do a lot of labeling, and then we can solve it. From this angle, I know adjacent. I need opposite, right? Because hypotenuse is across from the 90, don't really even care about it. Opposite and adjacent, I'm going to use tangent. So I'm going to fill in what I know. Tangent of my angle, and I know the angle this time is 29.5, is going to equal opposite, which is x, over adjacent, which is 36. I always kind of like this setup, instead of having the x in the denominator. That's usually kind of a pain, because there's just one step to solve it, and the step to solve it is we're going to multiply both sides by 36. And then I'm just gonna kind of throw that in my calculator to find my final answer. So 36 times 7, that's 29.5, equals 17.7. And that's meters. So there you go. So those are the first two, kind of easing our way into it. Excuse me. So if nothing else, you write it down. Oh, excuse me. I'm just giving people a second if you missed something or if you're fixing something. And then we're gonna look at the next two, and I'll give you a few minutes after we set those ones up.
For the second one, I got 20.36.
Do we have the same setup?
Yeah.
Oh my God, I put sine. What was wrong with me? Sorry, guys. I totally hit the wrong thing. So let me redo it. 36 times tangent, 29.5. You're right, it's 20.4. Why is everyone crazy? I don't know why I hit the sine button. So thank you for fixing that, because sometimes I just go crazy. I said tangent, yet I hit sine, so thank you. All right, any problems besides just me being a crazy person? Okay, great. So we're gonna look at 5 and 6. Once again, we'll kind of do 2 at a time. So number 5, we need to know the height of a building. I need a new marker, but I just opened this one yesterday. No markers today. We need to know the height of a building to estimate the cost of a job. So whether they're painting or doing something. So we have a building. Okay, as you can see, my artistry is very, very advanced here. Nice little everything. From a point 99 feet away from the base of the building. So there's a point somewhere over here, okay, and it's 99 feet. The angle of elevation to the top of the building. So from here, the angle of elevation to the top of the building is 42.2 degrees. Ignore that minute there. I think I erased it and then didn't really erase it. Okay, so that wasn't that bad. Find the height of the building. So not a terrible setup, not even too terrible to read. You're gonna label what do you know from the angle, what do you need from the angle, what trig function, and then you're gonna write an equation and solve. So we'll do that in a second. You guys will kind of try that one and try to finish it up. But let's set up 6 while we're here. We'll do kind of 2 at a time. Excuse me. So number 6, you're sitting atop a tree. Okay, that's beautiful. So here I am. There's my little face popping out of the tree. Okay, so I'm sitting up there. Oh, look at my pal Joey. Hey, Joey, what's up? Joey's down here somewhere. I don't know why I made you with no legs. I am sorry. Okay, there you go. You're just sitting there. The angle of depression. So once again, me, there's Joey. We got a nice right triangle. Okay, so the angle of depression, as I'm looking down, is 51.5 degrees. Remember, depression is from a horizontal, you're looking down. It's 41.5 degrees. And that doesn't really help me once again because it's not in the triangle, but that is always the same as this one. So it's kind of funky like that, but it always works out that way. So that's kind of nice. Joey is known to be standing 29 feet from the base of the tree. So from the base, he's 29 feet. And I want to know, how tall is the tree? These are very similar setups. They're just kind of the numbers are changed. So from my angle, what do I know? What do I need? What trig function am I using? And then can you set up an equation and solve it? All right. So you guys are, once again, a few minutes, just see how you can do something. Even if you don't finish it, I'm happy if you've tried. So we'll take a few minutes to try those. And then we'll do kind of our last set in the few, and then we'll wrap it up from there. So I'll give you a few, because once again. All right, so we can go over these ones. Once again, they look almost like the same exact triangle. So for both of them, you know adjacent, and you need opposite, which is tangent. So then I just try to make my equation. Tangent of my angle, which is 42.2 degrees, equals opposite over adjacent. And then the only thing I need to do is multiply both sides by 99 and plug that into my calculator to get my final answer. So 99 times the tangent, I actually hit the right button this time, of 42.2. X is gonna come out to about 89.8 feet. That's my building. And the nice part was, once again, 6 was the same exact setup. We just changed a few numbers, but everything was kind of in the same spots. So I know adjacent, I need opposite. I'm gonna use tangent. Oh, I don't even know what I just did. So my equation, I'm gonna just do tangent of my angle, which is 41.5, equals opposite over adjacent, and I would just multiply both sides by 29 to solve. Throw that in my calculator. Oh gosh, I just hit a bunch of weird things. Sorry, I was just hitting weird buttons there. And that would give me about 25.7, and that would be feet. Well, I'm pretty tall from that tree. So those are all kind of similar. You're finding a building, a tree, whatever. A lot of them you're finding the height of something. So just depending on what you're doing, the main goal is to draw that picture so you can visualize it. Now the last two that we'll kind of wrap up with are a little bit different. It's not necessarily giving you like a scenario, it's just kind of giving you a triangle and you need to know how to set it up. So we're talking about isosceles triangles in number 7 and 8. And an isosceles triangle means two sides are the same length. So in number 7, when it says isosceles, it's going to look like this, which does not look like the triangles we've been dealing with, because we've always had right triangles. We don't have that right now. We know that two sides are the same. It tells me the base has a length of 49.28. Okay, so that wasn't bad. It tells me the angle opposite the base, so if this is the base, the angle opposite the base is 58.746 degrees. That's my angle. And then it says find the length of these two sides. So these two sides are the same. We need to find one because then the other one's the same thing. But we're saying, well, I don't know how to do that because we can only do all of our steps with right triangles. So there is a little hint. We're going to divide the triangle into two right triangles. So basically what we're going to do is just take this center and go right down the middle with a vertical line. Because now this is a right angle on either side. And then we're just going to do our math with 1/2 of the triangle because then we can do the steps that we know how to do. So let's say we just look at this half. It doesn't matter what half you look at. Now think about it. It's half. So I need to split the base in half, right? I threw that thing right down the middle. So I'm going to take the 49.28 and divide it by 2. That's going to give me 24.64. And I took this angle and I split it in half. So I'm going to take that 58.746 and divide it by 2. And I'm going to get, I'm not really good with this, 29.373. And once again, my goal is to find this side, right, that side. So we'll call that my X. So just looking at the half of it, the right triangle part, you're going to label, what do I know? What do I need? Trig function. And then you're going to solve. I'm too lazy, so I'm not going to write equation and stuff. So when you think about it from here, you know opposite. You need hypotenuse this time. Ooh, mixing that up, because right, that's across from the 90. So opposite and hypotenuse, what trig function should you use? And then can you solve it? And then while we're here, let's just set up 8, because then I'll give you guys a few minutes and then we'll wrap everything up. All right, one more, and it's kind of similar. There is one difference. It is isosceles. It does tell me that the base is 42.36 inches. And then it tells me this one has the base angles. So the base angles are these, right? It's not the angle opposite the base. The base angles are 38.12. So both of these are 38.12. My main goal is to find the length of the two equal sides. Same thing. Anytime you have an isosceles, you always split it in half. So you now have a right triangle. Or technically you have two right triangles. We're just going to look at one of them. So I'll look at this one. So I think about just that half. This base angle stays the same, right? That wasn't part of the piece that I split. I did split the base though, of 52.36 to give me 21.18. And then my main goal is to find this. So from here, from the angle you know, in this case you know adjacent, you need hypotenuse again. So what trig function would you use? And then can you set up the equation and solve? So the last few, I'll give you a few more minutes, we'll go over them and then we will wrap up today's class. Simpler. So I end up with x times sine of 29.373 equals 24.64. Kind of annoying to rewrite. You can kind of do it in your head if you want. But then I would have to get x by itself, since it's multiplication, I would divide by sine of 29.373. That would cancel that, and I would do the same thing over here. So this is what I'm plugging into my calculator. So you have to do a little bit of rearranging. 24.64 divided by sine of 29.373, and your x would come out to about 50.2. What a beauty. And last but not least, our final problem, finally of the day. Let's take a little bit. I know, so remember it's this angle, I know adjacent, because the one next to it. I need hypotenuse, because that's across from the 90. I'm going to use cosine, right, So I'm going to do cosine of 38.12 is going to equal adjacent over hypotenuse. So I'm getting lazy, so I don't want to write all the steps out, and my marker's starting to run out. I'm going to multiply both sides by x. And then to get x by itself, I have the 21.18, and I would have to divide it by the cosine of 38.12. So doing all those steps over there, I just get a little lazy trying to not write them out, and then I'm just going to throw that in my calculator. And that comes out to 26.9 inches. In that case. So those ones had a little bit more work just to kind of rearrange them. Stuff we've seen before. But that's it. All right, a lot of word problems, but basically we're pretty much